Assalamualaikum. We from Group 14. Today we want to present our assignment 1. The title is about solar power plant using photovoltaic cell.
Good day to Dr. Mamadno, and I'm Logeshwaran, present the outcomes of solar energy using photovoltaic cell. As we all know, Malaysia is one of the well-developing countries from different sector of field. Therefore, to continue its achievement on mission and vision towards 2020, country needs to establish more power supply as it play main role in drive the economy. One statistic shows that the currently electricity generation in Malaysia increased an average of 8% per year from 69280 gigawatt per hour in 2006 to 137,909 gigawatt in 2016. In Malaysia, they contribute two types of energy, which are renewable and non-renewable energy. But under the 10th Malaysian Plan, the Malaysian government wants 5.5% of total electricity to come from renewable energy sources by 2016. First of all, what is renewable energy? As we all know, renewable energy is generally defined as energy that is collected from resources which are naturally replenished on human timescale, such as sunlight, wind, rain, tides, wave, and geothermal heat. But here they choose to generate solar energy using photovoltaic cell by convert light into electrical current using the photovoltaic effect. The negligible contribution by solar energy is due to several reasons. One of them is the lack of awareness among Malaysians about the use of solar energy for electricity generation. However, the largest hurdles to solar energy adoption are the high cost and low efficiency of solar panels or photovoltaic cells.
A good day to Dr. Mohammad Noor, our beloved lecturer. I am Ganesan Rajasekharen. I would like to present about the working principle of solar power plant using photovoltaic cell. This is the basic general diagram for solar power plant. As light hits the solar panel, the solar radiation is converted into the direct current electricity DC. The direct current flows from the panels and is converted into alternating current AC by using local electrical utilities. The extra energy will store in the battery bank. Finally, the electricity travels through transformers and the voltage is boosted for the delivery onto the transmission line so local electricity utilities can distribute the electricity to homes and business. Now I would like to explain about part and function in the solar power plant. First, photovoltaic solar panel. Solar cells are converted take the energy from sunlight and convert into electric energy. The array of solar cells converts solar energy into usable amount of direct current electricity. Next, DC link. DC link is a ADC link is connection which connects the rectifier and the inverter. Third is battery unit is to store the extra energy of electricity. Fourth is inverter. Inverter is a power inverter that converts direct current DC electricity into alternating AC, which ability to synchronize the interface with a utility line. Its application are converting DC source such as solar panels or small wind turbines into AC for tying with a grid. Next is transformer. Transformer is generally used for stepping up and stepping down the voltage level of power in transmission line power system network that produce from the for solar power generation. Next is transmission line is to transmit the electric power from the transformer to a domestic usage in the substation. Then circuit breaker. Circuit breaker is an automatically operated electric switch designed to protect an electric circuit from damage caused by overcurrent or overload or short circuit. And finally, utility grade AC power. Utility power is automatically provided at night and during the day when the demand exceeds your solar electricity production.
Hello, My name is Sharvina Raj and I will be explaining about the potential of solar power plant in Malaysia. Being located in the equatorial region, Malaysia is exposed to ample and constant sunshine, an ideal environment for solar photovoltaic power generation. Malaysia receives an average of 17 megajoules per square meter of solar radiation per day. All regions in Malaysia have sufficient availability of land for photovoltaic installations, except for Kuala Lumpur, where the solar photovoltaic capacity is limited to 5 gigawatt due to the limited area and locations for solar photovoltaic installations. As we can see, the graph shows Malaysia's cumulative solar photovoltaic capacity in megawatts from the year 2013 to 2015. Solar energy is good to be used for smart energy networks with distributed power generation, which is considered the future generation power network structure. When compared to other renewable energy systems, photovoltaic panels requires low-cost operation and maintenance. To prove this fact, photovoltaic still powers every satellite circling the Earth for a long period of time with virtually no maintenance. Photovoltaic power generation will coincide with the energy demand peaks, especially in summer where the demand is high, thus providing an effective solution. It is also the perfect choice when considering urban and residential areas, for it produces no sound disturbance. To add to the good side, photovoltaic power generation system can be constructed to different sizes based on the energy requirements and can be enlarged to change in the energy needs. The current contribution from renewable resources such as biomass, biogas, wind and solar for electricity generation remains very low, of which solar energy only contributes a mere 0.007% of the total generated electricity in Peninsular Malaysia. The negligible contribution of solar energy is due to several reasons. One of them is the lack of awareness among Malaysians about the use of solar energy for electricity generation. However, the largest hurdle to solar energy adoption are the high cost and low efficiency of solar panels or photovoltaic cells. Solar panels for either thermal or electricity purpose can be mounted on rooftops. Although the rooftops of houses and buildings are said to be dead space because they are unused, not all rooftops are suitable to be mounted. It is estimated that only 2.5 million houses and 45,000 commercial buildings in Malaysia are suitable for solar panel mounting. This is because the design and orientation, as well as the external environment of the buildings, would affect and harvest of solar energy. A study by UKM shows that none of these solar panel types had more than 10% efficiency in converting solar energy into electricity. The low efficiency of photovoltaic panels sold in Malaysia is bad news because a great deal, which is more than 90% of solar energy, is unused for electricity generation. The implication is serious, in which a very large area of solar panels, cost notwithstanding, would be required for utilizing solar energy for electricity. Consequently, solar energy, as well as other renewable energy, cannot be a major contributor from electricity generation in Malaysia. This would be true until solar technologies become affordable enough and the technologies become much more efficient in electricity generation from solar energy. At the moment, solar energy, at best, could supplement Malaysia's energy supply.
The impact of solar power plant, it will impact the land use and ecological impact. The solar facility could impact the use of neighbors specially designed areas such as wilderness area of critical environmental concern or special ration management area. Then it will impact to the soil, water and air resources. The construction of solar facility on vast area of land impose clearing and grading result in soil compaction, alternating of drain channel and increase the erosion. Then the impact hazard materials. The PV cell manufacturing process include a number of hazard materials, most of which are used to clean and proof the semiconductor surface. This is limitation of solar panel. The solar panel is that obvious cannot be created during the night. Then the power generated is also reduced during time of cloud cover through energy is still proceed on a cloud day. Then solar panel energy output is maximized when the panel is directly facing the sun. It will reduce energy production when the sun is not at optimal angle.
Photovoltaic technology produces the solar power. During this process, some collecting devices absorb the particles of light known as photons. The energy produced will then be released during the process of absorption and will be transferred as the electrical current. To produce solar power plant, you will need solar cells, or also known as photovoltaic cells. These cells need to be exposed to the source of the solar energy, which is sunlight. It generates electricity when the sunlight hits the solar cell. When this happens, the negative and positive charge can now be directed and controlled using a cable. Now, when enough electricity is generated, a cable will direct it to an electrical inverter. Electrical inverter changes the direct current into an alternating current. This will then be stored or distributed for usage. For storage, most solar power manufacturers use rechargeable batteries. This will allow the energy to be used for a later time when needed. So, the more rechargeable battery being used, the higher storage capacity it is for usable energy.
Conclusion: Malaysia has a strong potential to build large-scale solar power due to its location at the equatorial region. The continuous supply of sunlight, silent in operation, low maintenance cost, independent of fuel source, the environmental friendly factor, and contribution to lower carbon emission make solar the best choice for future energy power generation. In Malaysia, more effort in research and development on solar energy are required in order to overcome the barriers to enter the PV market in the country. One of the major barriers for solar energy is the economic barrier, where the capital investment required is very high with regards to the awareness and understanding of PV technology. Educational programs should be introduced not only at universities and college level, but also primary and secondary school level. In addition, to encourage rapid widespread of PIBV adoption, the media play an important role. Mass media should have special segments to focus more on solar technologies. In conclusion, a strong government policy on solar energy field is crucial to support PV market growth. A healthy competition among industry players and the new PV manufacturing industry must be promoted. Thank you.